Do you know which module you have to instantiate to use the full capability of regular expression in Python? Do you know how to do the basic matching and group matching using the regex in Python? Do you know how to do the search and replace using the regular expression in Python? Do you know how to detect the multiple occurrences of a text from a log file? Stay tuned till the end of the video to know all the answers.
Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the regular expression module, that is RE module, and its compile method to deal with the regular expressions. In the first slide, we will go in the detail of this RE compile method. Next, using this RE compile method, we will do the basic pattern matching, definitely through code example. Next, we will do the group extraction for a pattern. We will extract groups. So we have multiple groups inside a single string and we will extract all of these groups. You will understand once you see the example. That's why this entire episode is flooded with examples of Python code, which at your end you can simulate with Genie, and you can download the codes directly from the links given in the video description and from the GitHub website. Next, we will do the search and replace operation using the re.compile module. Next, we will do the splitting of a string with respect to a pattern using the re.compile module. Now, this is very different from the basic splitting which we have done in the string episode. Next, we will detect multiple occurrences of a particular pattern using the re.compile method. So this will be very useful because when you are parsing a log file of any EDA tool output in VLSI world, there you have to check for a pattern whether and how much time it is coming. That pattern you can detect how many occurrences have been there in the log file. That's the menu for today. Without any further delay, let's begin. Let's talk about the Python re.compile method. Regular expressions are compiled into pattern objects which have methods for various operations such as searching for pattern matches or performing string substitutions. Generally, we do the matching and substitution, and sometimes we extract in groups. So these are the common things that we do in the regular expression world. Whether we are dealing with Perl, whether we are dealing with Bash, or whether we are dealing with Tcl, or maybe we are doing with Python. In all of the cases, what we do most of the times is a pattern matching, do the substitution, group extraction on all of these things. And obviously there is another important, the splitting of string with respect to a pattern. Next, re.compile takes a regular expression pattern string as its argument and returns a compiled pattern object that can be used for various pattern matching operation. Now, this particular part, the compiled pattern object, let me highlight again the compiled pattern object. This is very much different from the Perl or Sed or Tcl. This part is compiled first. In the background, it will do some C++ compilation for the regular expression. As we have talked about the regular expression in last episode, that it is a feature of the POSIX. By connecting to POSIX, the compilation will be completed, and that compiled regular expression will be ready to use not only single time, multiple times in the Python code. Compiled pattern object can be reused for pattern matching, especially when performing multiple matching operations. That is just what I have said. The compiled pattern object provides various methods for pattern matching such as match, search, find all, find ITR, and more. So these are few things that you will come across in upcoming examples. It also allows for advanced operation like substitution and splitting based on the pattern. So these are two very important, the substitution and the splitting based operation, because in VLSI, when you are, say, you are having a Verilog code, you are having a Python code which is reading the Verilog code and modify it according to your need. So at that time, you may require to substitute something, or you may require to split and take the arguments, the splitted arguments, into your variable or array like structure and then reuse them. So that thing can be done easily using these methods. And the final output Verilog code will be something that is target. I have just talked about an example in VLSI how these things happen, because most of the cases there will be a sample parent circuit and there will be places where you need to replace things to get your case specific Verilog code. So once you are in front end, you will come across all these things. By compiling the pattern, you can set additional flags to modify the behavior of the regular expression matching, such as case insensitivity or multi-line matching. So these are some advanced things, that is the multi-line matching and case insensitivity. That means whether the text can be in uppercase, lowercase or mixed case. So these are advanced things. So you will have additional flags. Additional flags we have not covered in this episode. We will cover later. The compiled pattern object supports both BRE and advanced regular expression syntax, that is ERE. So BRE and ERE are the property of the POSIX, and by compiling the code, that is the regular expression code, it is connected to the POSIX, thus enabling complex pattern matching capabilities. That means it connects to the POSIX through the compilation and enables both BRE and ERE. Obviously there will be flag to control either of them. Generally we use ERE, that is the advanced one, because that is a superset of BRE in usage perspective and features perspective. Using re.compile helps to improve the code readability and maintainability by separating the compilation of the regular expression pattern from the actual pattern matching operation. So we split the two things. One, we compile, then we match. So this one will stuck in case you are writing something wrong and you will not move to this step. Here you have to correct at the compilation and then you have to do the matching. So once you're compiled in without any error, you can proceed for the matching. So that means your entire process is split into two halves. One half is correct, then you will go smooth on the other half. So we are done discussing on this slide. Let's move on to the next slide. Basic pattern matching. First, we have our hashbang user bin Python 3, that is the interpreter. Next, we import the RE module. Remember, we are importing the regular expression module and this is a must. So in case you forget to write this line, the code will be defunct. Next, we have a variable and we compile the regular expression using re.compile, and in the argument we give R means raw, right? And we give A, B plus C. Plus, what does plus means? You can recollect from the last episode, okay? And we compile the pattern here. Next, we have done the compilation here. Now we have to use this pattern to match, right? Then we are using the pattern and we are using the method match and we are giving the argument A triple B C, right? That's the matching. So we will now check the result. If result is true, then print match found. That means this will be either 1 or 0 as the matching result. 1 is true, then it will go to the if and go to this particular segment of code. Else, that means when it is 0, it will go here, right? This one, the no match found. This is a very simple code and we write our regular expression here. This one is our regular expression and this is our target string. So we can have this string somewhere else in other variable and we can pass that variable here also. Okay. Once we run this particular code, we find that the output in the terminal is match found. That means this plus means B, that is multiple times B is matched, and hence the result has come as 1. And by this 1, we proceed to this line and we see the match found, and hence the output is match found. You can download the code from GitHub. The link is in the description. Go ahead, run it, do some modification, try out your different regular expression that you want to do with this particular code to see whether your given regular expression pattern, that means this thing, and the target are 1:1 matching or not matching. We are done with this particular slide. So let's move on to the next slide. Extracting groups from a pattern. So in this particular slide, we will identify different groups of texts with obviously different set of regular expressions, and we will try to match them from a given string. First line goes as the interpreter. Next, the most important line, we import the RE module. Next, creating groups using first bracket. Next, we compile our pattern and store it in a variable, and our compilation is pick this one. So here we have \d, that is 3 times \d, that is 3 times, and backslash d 4 times. Backslash d, you remember, right? It could be a range from 0 to 9. I have already explained in the last episode. In case you are not able to recognize, please go ahead and watch that episode. So what it will do, it will scan for 3 groups of numerics, first, second and third. The first 2 will be of 3 digits length and the fourth one will be 4 digit length. Now we apply this pattern here and using the match function, and this is our target string, that is 123-456-7840. Remember, we have already put a dash here and dash here so that we can segregate. Now remember, we have first level of parentheses here and the second level of parentheses here. Only 2 matches are there. So there are 2 groups. One is this, another one is this. However, we have used 3 different set of regular expression matching. So this return value will be either true or false, that is 1 or 0. Next, if the result is 1, what will happen? Area code result, then group 1. So this first one, it is termed as group 1, first group, and this is the second group. So this will be second group. So we have result dot group 1 and result dot group 2. In case it is coming as a positive, we will have all these 2. To access the groups, we have to use the method called group, and we have to give the index 1 for the first group and index 2 for the second group. The first group we have stored in the variable area code and second one as phone number. Next, we have print command, and there we are printing the area code, that means this one. The next print command, we are printing the phone number, and we are printing the phone number here. Else, if we do not match, that means we have a 0 result here, sorry, not here, 0 result here, we will reach that no match found. So if true, it will go here, and if false, it will go here. Once we run the code, we get the output that area code is 123 and the phone number is 456-7890. So you can see we have the first group matching here and the second group matching here using the regular expression this and this. So this is the way you can do the group matching. Now in this case, we have all numerics. It could be alphanumeric or only alphabets. As per your requirement, you can change. You can download this code from the GitHub. The link is in the description. Go ahead, modify this and these as per the learnings from the last episode. Change it as you want and then run the code and get the output and see whether you are getting an expected output or non-expected output. Here we are done with this particular slide. So let's move on to the next slide. Search and replace. The search and replace we do every day in our text processor. We find some particular word and we replace it with maybe one word or a phrase. So that thing you have to do within your programming language. That means here we are doing it in the Python. What we have to do? Let us see our example code. Code starts with the interpreter. Next, we have the import re. And this is the most important thing. If you do not write it, the code will not be running. That means the entire rest of the code here shown here will be defunct. And one more thing, in case you are using the Windows, as I have shown earlier in the installation and the usage episode, this line you need not to use within Windows. That means this line can be omitted easily when you are writing the code in Windows. Next, we have the compilation coming up. We write pattern, then re.compile, and here we write our regular expression \b, then apple, and then \b. What is \b? In case you do not remember, go ahead back to the last episode. There I have explained in detail. Next, we have our text. This is our text, and we have apple here and we have oranges here, right? This substitution, what we are going to do is a non-destructive substitution. That means this particular variable and its content will be unaltered. Whatever is modified will be coming as the output and we can store it in another variable. So this is our new variable which will contain the non-destructive substitution. That means this will be unaltered and whatever changes as per our substitution will come in this particular variable. And what code we have to write? We have to write pattern. That means this is our compiled pattern. Then sub. Sub is the method which use the search and replace. That means this is the thing that has to be replaced. And this is what we are searching for. Remember, this particular method will contain only the substitution part in the target text. That that is here given, and here we have to give the search pattern, right? Now remember, the search and replace is not in a single one, so it has been past part 1. Here we are doing the compilation of the search, and second part here we are doing the substitution. So this word we have to find and substitute with this particular word in the target this text. So text is this one. So you remember carefully, because in our text processor we have side by side words, but here first we compile and then we substitute using the import re method. There are other methods of the substitution that I have already discussed. So that is the basic string replacement, but using the regular expression, when you have to replace the thing using the regular expression, you have to follow this method. Next, we print our updated text, and once we run the entire code, we get the output as this. I have an banana but I prefer oranges. So earlier it was I have an apple but I prefer oranges, and we have find apple and substitute it with banana. Hence, this text has become here the new one. But one thing you carefully notice, this is unaltered. That means this variable, the content of this variable is unaltered. Whatever we got in this particular variable. So these are two different variables and these two have different contents. Okay, so we are printing only updated one. So this is a non-destructive search and replace. Okay, so here we are done. Before moving, where this can be used? This can be used, say you have a parent spice deck or you have a parent Verilog file, which is their simulation. You have to modify multiple parts of that file. So this is your parent file, and say here you have to modify, here you have to modify, here you have to modify. Not the same thing. This is different, and this is different things you have to modify at different parts. For that, you can compile multiple patterns, so pattern 1, pattern 2, pattern 3, pattern 1, pattern 2 and pattern 3, and you can parse the text and modify at this particular lines. Okay, and there you can replace the things and get a derivative, either a Verilog file or a spice deck. So these are common because nowadays in the front end you will have mixed signal simulation where both the spice deck and the Verilogs are simulated together. So this is fine, and let's move on to the next slide. Splitting a string with respect to a pattern. Now earlier we have done some splitting, but that is a basic splitting. Here we are doing the splitting as per a regular expression pattern. So this is different from any earlier splitting we have discussed as a basic string splitting. And here we can do the pattern compilation using the re.compile module. So let us start the code. First line, obviously the interpreter, this one. Next we have the most important line, import re. Next we have the delimiter, non-alphanumeric characters. This is our comment, and here is the code, right? The pattern is re.compile is common, and here we are giving the \w plus, so non-alphanumeric characters. In case you are not able to remember, please go ahead to the previous episode in this series, and there I have detailed explanation of this W. Next, our text under consideration is this one. Next, we have a non-destructive split. Again, here we are doing a splitting which is non-destructive. That means this particular variable and its content will remain intact. Whatever we'll get as a output will store into a different variable. So here we have words which is different from text, and there we are using the compiled pattern and we are using the split method, and there we are giving the sample text. And once we done this, next we will print the words. So this will be a list or array, whatever you understand. So this will be a list, and once we run this entire code, what will be coming as the output? So there will be different things like this is a sample sentence, and there is a space character also. So here we have done the compilation of the delimiter, and here is our target text, and here we have done the non-destructive splitting, and as a result we are getting this list or array, whatever you say, and the elements of that particular list or array are this, which are comma separated, and you can see it. Go ahead, do the changes here and here. You can download the code from the GitHub link provided in the description, and from there you can change this particular code with other different things as well as the target string, and do the trial and error to see how you are getting efficient on the pattern matching. We are done with this particular slide, so let's move on to the next slide. Multiple occurrences of a pattern. So this is very important when you are parsing a log file of a EDA tool output. Say whether this generally when we read a log file, we look for either error, warning, or there could be messages. So W, and M. These things we generally search for in a log file. And obviously this, and there could be another thing, F, that is the fatal. That means with this the tool has stopped running and not proceeded anymore. So these are the common things that we search in a log file. But for that occurrences, to find that occurrences, we have to do a multiple occurrences search. So a simple code will be shown here, not the log file one, that you can develop at your end when you are pro with the Python coding. So here goes our first line, that is the interpreter obviously. Next one is the most important line, the import re. And here we are doing the find the numeric patterns. So we have the pattern and then we have the re.compile method and we are using \d+. So in case you are not able to recall, please go ahead and see the previous episode. There we have talked about these things. Next, we have our target text and here all these things are there, which we will do the searching. Next, we have our match part and matches, and here we have the pattern which is compiled from here. So this compiled one comes here and we invoke the method find all, and here we give the text. Text means this one. So this one we have compiled the regular expression and then we are applying it on this particular text through this particular command. And finally, we print the matches. Once we run the code, we get the output as 1, 2, 3 and 4, 5, 6. So this is the numerics, right? So we have two set of numerics with multiple occurrences here and here. We have find out all of them, right? This. So go ahead, download the code from GitHub, link in the description, do the changes here and here as per your creativity and try out the code and see how you are getting used to the regular expression in Python. So here we are done. Let's move on to the next slide. Thank you very much for watching up to this point and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.